Now another type of similar memory is called the FIFO buffer, or the queue, FIFO meaning first in, first out. And the way that works is, if you look at the examples, they'll say it's like people standing in a line. And so here's people standing in a line at the grocery store. I'm not going to draw the carts, it'll take too long. Here they are, and this person checks out, and then everybody moves. And then that next person checks out, then everybody moves, and the other people get in line. And so the first in is the first service, so first in, first out, or FIFO, or a queue, depending on who's talking. Now, of course, this is not really implemented where we move the memory around. That would be too labor intensive, if you will. It'd take too much time. So we don't actually move the data. We just have a pointer. So let's take a look at our bit of memory where the FIFO buffer is. And I'll start from the back and work forward, but could be the other way around. So there's the first person, there's the second person as they get in. Now the pointer is going to say, okay, there's the last person in line, there's the first person in line. And so it's going to deal with this data here and then move the pointer up. Okay, now deal with the next bit of data. I'm just showing them as a byte. It would be maybe bigger pieces of data. But the data goes here, the pointer goes there. When that data is used, instead of moving all the data down the queue, it just simply moves the pointer to the next piece of data in the queue. So if we go back to the people standing in line, when this person gets checked out, the check stand moves over to the next person. When this person gets checked out, the check stand moves over to the next person, and so on. And then what happens when we run out of queue memory? Well, the check stand just moves back to the beginning. So as these people are used up, they are replaced with new people. I'll do them in green. And this person gets up, he's replaced with the new people. And the pointer just keeps moving down the line. And then when we're done with this guy, the pointer just simply goes back to this guy. So as they're used up, we put people back over here and the pointer moves. So when people describe the queue or the FIFO, they describe it like, oh, the information is moving through the buffer. Now, the information stays in the buffer and a pointer moves through the buffer. Once again, it's like the check stand moves down the line instead of the people moving toward the check stand. So that's the way the computer would do it, because it's a lot easier to move a pointer than to move data. You have to take the data, put it in the processor, take the other data, move it, and take this here, put it in the processor, move it there, move. It takes a long time. It's ridiculous. We would not do that. We just simply move a pointer. So that's how a queue would work. So queue, the idea is that we have a first in, first out. It's like a bunch of people in line. One person gets serviced, everybody moves up. But the way it's practically implemented is we have blocks of memory with data in them and a pointer to the front of the line, and the pointer moves as the data is used. And then when we get to the back, we have new data and it moves back to the front. And so the data doesn't move, actually the pointer moves. So that's how a FIFO or queue works. One place you might see a first in, first out data structure or a queue would be in a network switch. So we have a switch, which I'll just draw as a little box here. We have a number of Ethernet cables coming into it, or whatever kind of network cable we have. And inside is some circuitry, so that, let's say a packet comes in from this port here, that's going to go into some memory and be stored to be ready to send out another port at some other time, usually very quickly. So that packet goes into the memory, and while it's getting ready to go, and maybe even while it's transmitting, another packet might come in from another port and also go into the memory. So if we look at how the memory is organized, we want the first packet to come in to be the first packet to go out. So we have a queue or a FIFO buffer. And so here's how the memory is arranged. And so I'll do it from left to right here. So the first packet comes in and it goes there, and then it's processed. So the pointer to the memory that's being processed would be pointing to this block here. Meanwhile, another packet comes in, and when this one's processed, the pointer goes over to this one and starts to process that packet. And in the meantime, we might have several packets come in waiting to be processed, and as they're processed, the pointer moves along through the buffer, processing that packet, then that packet, then that packet. Finally, we get to the end of the buffer, and by this time, all these other packets have been processed, and so this memory is going to become available. So once that's used, then we can go back and start using this memory over again. The only problem we might have is if the network gets really busy, that buffer could fill up. It doesn't happen too often, but it can happen. And then we have what's called a buffer overflow. And most of your desktop switches would be, your inexpensive switches would just simply turn into a hub, and they would block any new data coming in until old data has been processed. But good quality, high quality enterprise switches would have enough speed and buffer to handle something like 90% of the bandwidth that would be handled by all the ports together. So, but anyway, that's where a good place to think of where you might find this Q or FIFO buffer is inside a switch, where the first packet to come in, you want to be the first packet to go out. So there's a look at some of the data structures you will find if you make a formal study of data structures, and I'm going to look into tree-type data structures, find out how they are implemented and where they're implemented, so I can relay that information to you. In the meantime, my next video is going to be a look at some real data structures you might use in database management, some structures that you probably won't see if you make a formal study of data structures, at least if you just do a short overview of them. I'm going to show how to take the data as it's structured, or at least visualized in a database management system, and how to organize that data in such a way that it's efficient and easy to retrieve, at least for a computer, and to present that data in a human usable form. So if you think this video is useful and informative, please give me a thumbs up down below. It really helps the channel, and don't forget to subscribe. Hit the gray bell when you do. And as always, a big thank you to my patrons and my members and other people who are making donations and making this possible. And thanks to everyone for watching.